Hello, my name is Jordan McCaskill, and today we will be looking at the areas in physics of electricity and magnetism. We will be looking at the history of each, the importance of each, the different applications of both topics, and how they will change not only the future of physics, but how they will change the future of our lives. So let's get started. The first topic we're going to talk about is the concept known as electricity. First, let's get a better understanding of what electricity really is. The definition can be explained as a type of energy that is created due to the existence of charged particles that work together to create either a static or a dynamic source of energy. These charged particles are called protons and electrons. Protons are positively charged particles and electrons are negatively charged particles. Electricity has always existed, but many years ago we did not have the knowledge or resources that we have today about it. Benjamin Franklin and Thomas Edison made it possible for us to have the things we have involving electricity today. Ben Franklin is credited with the discovery of electricity and how it can be harnessed for our benefit. He had a theory that lightning could be used to create electricity, so he conducted a couple of experiments. The first one was the kite and metal key experiment, where he thought the key would attract the lightning from the clouds, which it did. The second experiment is the lightning rod experiment, where he attached a lightning rod to the top of his house, and when the lightning struck it, it would illuminate his house with the electricity. Thomas Edison came after Ben Franklin, and he was able to use what Franklin did and create the light bulb. There are several different reasons why electricity is important to us as humans. First off, we need it for survival. Are there people out there who survive without electricity? Yes, but we use electricity in our everyday lives for so many different things, such as to see at night, to store our foods in a refrigerator or freezer, for transportation, to heat our homes at night, to use phones or computers, and even just to brush our teeth. All of these reasons of importance would not be existing if it wasn't for the people before us, such as Ben Franklin and Thomas Edison. The next topic of physics that we will be covering is the concept of magnetism. According to Jim Lucas from Live Science, magnetism is one aspect of the combined electromagnetic force. It refers to physical phenomena arising from the force caused by magnets, objects that produce fields that attract or repel other objects. The motion of electrically charged particles gives rise to magnetism. The force acting on an electrically charged particle in a magnetic field depends on the magnitude of the charge, the velocity of the particle, and the strength of the magnetic field. Magnetism is similar to electricity in that magnets have a north and south pole. The north pole is attracted to the south pole of the opposite magnet, and the south is attracted to the north pole. Like charges repel one another and will not attach. Magnetic fields affect moving charges, and moving charges produce magnetic fields. Changing magnetic fields can create electric fields. This phenomena signifies an underlying unity of electricity and magnetism, which James Clerk Maxwell first described as the ultimate source of any magnetic field is electric current, according to Sir William Ville of College Science. The history of magnetism can date back many, many years, and the studies of it can be credited towards many people. However, a couple of scientists that I would like to mention are William Gilbert, an Englishman that was the first to investigate the phenomenon of magnetism systematically using scientific methods, and James Clerk Maxwell, who provided the theoretical foundation to the physics of electromagnetism in the 19th century by showing that electricity and magnetism represent different aspects of the same fundamental force field. Both of these men are highly praised for what they have studied and discovered. William Gilbert correctly concluded that the Earth must have an iron core which generates a magnetic field around the entire planet. He postulated that Earth's magnetic poles corresponded to its geographic poles, which was why compass needles pointed towards Earth's North Pole. James Clerk Maxwell introduced his pivotal theory of electromagnetism. Among the tenets of his theory were 1. That magnetic waves travel at the speed of light, and 2. That light exists in the same medium as electric and magnetic phenomena. Magnetism is used all around us. Large electromagnets are used to pick up heavy loads of metals. Magnets are used in devices such as meters, motors, magnetic tapes, and discs. Even MRI machines. MRI machines are also an extremely important invention that is used to explore the human body with high quality imaging resolution. This machine allows us to see that things that our eyes cannot visually see, deciding whether or not surgery is needed in the recovery process. And even the little things such as using magnets to hold your grocery list on the refrigerator. All of these things are present in our everyday lives. Now that we know what electricity and magnetism both are, let's see how they compare and contrast to one another. As you can see in the picture, we have made a list of related and non-related characteristics of each. Some similarities are that both create a pulling force on objects, opposites, opposites attract, both are based on electrons, both have fields involved, referring to an electric field and a magnetic field, which creates that pull or pushing of an object. The further the objects are apart, the less force they have on that object, and both have the ability to lose charges. These two factors come together for what is called electromagnetism. An important theory that took place in order to find the relationship between electricity and magnetism is James Clerk Maxwell's theory. He made a series of predictions involving his research. First, electric field lines originate on positive charges and terminate on negative charges. Second, magnetic field lines always form closed loops. They don't begin or end anywhere. Third, a varying magnetic field induces an EMF and hence an electric field. Fourth, magnetic fields are generated by moving charges or currents. After conducting his theory, he decided to prove them. He ended up concluding that visible light and other magnetic waves consist of fluctuating electric and magnetic fields traveling through empty space, with each varying field inducing the other. Here's a set of equations that Maxwell used that together form a complete description of the production and interrelation of electric and magnetic fields. An important law that should be taken into account when talking about electricity and the magnetism of objects is Coulomb's law. Charles Coulomb experimentally established the fundamental law of electric force between two stationary charged particles. It was eventually named Coulomb's law. The formula is F equals K times Q1 times Q2 divided by D2, where F represents force, K represents a constant known as Coulomb's constant, Q1 and Q2 represents the magnitude of the two objects, and D represents the distance. So how will electricity and magnetism affect our future? Our world is changing and getting better every day. New discoveries are being made every day. Physics itself is constantly getting more and more advanced. So, how will electricity change? Well, look at what we are doing with electric vehicles. The more places you go, the more electric pumps you see, and the more electric cars are being built. One of these days, electric vehicles is all we are going to know. Another way electricity could change our future is farming. Farming could possibly be brought indoors by using an indoor agriculture exhibit. For magnets and magnetism, there are several ways as well that it can change our future. Maglev trains are being produced more and more worldwide, which are lightning fast trains that travel on magnets. Hoverboards or hover cars could be a possibility as well. So I'm sure you have heard of self-driving cars. Well, they're doing a research study to put magnets in the roads to act like tracks to guide these self-driving cars in order to make them safer to the public. The future is unpredictable, and the sky is the limit for what we as a human race can discover next.